Gentlemen. Thank you, Sophia. We're going to do probability today. This is our last major topic, Mia. Probability. We got a couple little things we still have to hit, like transformations of functions, sequences and series, all that kind of stuff. Oh, Isaac, I did make a PowerPoint yesterday that we're going to use for finding sequences, like finding the nth term. I put it on the Facebook page. You can look at it if you want. But anyway, let's get started. You ready? So here's what probability is. I hate my life. Alright. Unfroze. Probability is, it's the likelihood, come on, Juba, of an event. Probability is the likelihood of an event. So, you know what I mean by an event? Do you know what I mean by an event? So something that happened, right? So an event is something in particular, like something in particular happening. Like, I don't know, some examples would be like, say it rained or it didn't rain. It's like the probability of it raining. Or how about probability of dying of cancer? Oh yeah. How about the probability of catching Ebola? Oh, isn't there like the new Zika virus? I don't know how to say it. Oh yeah, how about the probability of getting that thing? Yeah. Probability that global warming is either true or false. Or the probability that you win a game. You know what I mean by an event now? It's just something that happens. Like, what's the probability that Mr. Brown's going to get off task sometime today in his lesson? Probably pretty good. Probably pretty high probability. Yep. So probabilities occur on a scale. There's a scale for probabilities. And the scale, oh, I can't even spell scale right. The scale is from 0 to 1. The highest probability of something happening is 1. The lowest is 0. 0 means it's impossible. It's impossible. Like me not getting off task. And if it's a probability of 1, it's certain. It's going to happen. We're all going to die. Yeah. For sure, for sure. Good to go? Yeah. You guys, how many of you guys knew all of that already? Yeah, I figured. Okay. So, let's see here. Do you know what the difference, though, between probability and odds? So, like, you know, 2 days ago was the Super Bowl, and there was odds that the Panthers were going to win. It was like 13-9 or something. I don't know what they were. It's different than probability. Like 13-9, if that was a fraction, it would be more than 1. And the biggest probability you can have is 1, right? So probability is different than odds because odds compares yes to no. Like the ways, I'll show you what I mean. Whereas probability works this way. Yep. So the way probability works, Alex, is the numerator is going to be the number of ways that the event could happen, and the denominator is the number of ways that everything could happen, including the event. Whereas odds compares the number of ways it could happen to the number of ways it couldn't happen. A little different. Whoa. You know, I forgot my favorite event in my list of events. I forgot my favorite one. Yep, spontaneous combustion. It happens. Sometimes people just catch on fire from the inside. No, seriously, it's true. Human beings sometimes spontaneously combust. Like in real life, yes, for real. How does it happen? I don't know. It has something to do with the gases in our stomach. We don't know for sure. It's a mystery. Wow. Wow. Test it with Sophia. All right. So. No, that had to do with that. No, I don't think so. Off task would be that I got lost in the desert this weekend. This is a true story. I was with my cousin. Yeah. Well, all right. So we were out in the desert. Even though it's like winter, it was hot this weekend, right? I mean, it was pretty warm. And I came across a genie bottle. Yeah, a genie bottle, and I rubbed the bottle, and the genie came out and granted us 3 wishes, and I wished for a car door because it was really hot. So that's what I wished for, was a car door. Because it was really hot, yeah, and I wanted to roll down the window. I know, I'm sorry. I know, right? I just killed like 10 of your IQ points right there. All right. Yes. So let's say you're going to get breakfast, Alexis, in the cafeteria, and there are 4 orange juice containers left. That's it, just 4. Okay? And this is our cafeteria. So 1 of them is rotten, and 3 are good. Right? Probably the other way around. 3 rotten, 1 good. Right? And you have no idea which is what. Right? So, of course, you want a good one. So the event we're going to talk about is you picked a good one. You can't calculate probability without first deciding what your event is. Like the event could be you picked a bad one. Do you know what I mean? Like it could be either one. So we're gonna go with the event that we picked a good one. Okay, so here's how odds would work. Odds would work this way. It would be 3 to 1. Because there's 3 good ones and 1 bad one. Right? That's how odds would work. Probability would be 3 out of 4. Yes, sir.
So, like in sports and stuff, how do they come up with the odds? Do you just like ask people?
I don't know. They have some pretty fancy formulas they use, like where they compare teams that played against other teams and like how healthy they are. They have like a coefficient for that. And they plug it in this computer, and yeah. But basically, when they say the odds are 3 to 1, then they figure there's 3 ways that one team will win, and there's only 1 way the other team could win. So 3 to 1 odds means more than likely you're going to win. Yeah. But these are the same. It's just a different way of saying the same information. Questions? So let's see here. Let's make sure we got this. Probability. The most basic thing about probability is that the numerator is the event. It's the number of ways that the event could happen. And the denominator is all possibilities. Now don't be a smart aleck and say, well, it's possible that an alien giraffe comes and kidnaps me. Right? Like all possible events that are related to the experiment is what it's called. Yeah? Yeah? Okay. All right, I found this weird quarter. It's from 1972. I know you can't see it right there. Oh, yeah. Oh, blurry. This weird quarter from 1972. Man, it's not really... But it's weird. It's all dented. Do you see? And then on the other side, it's got different dents that don't line up with the other dents on the other side, like right here and here. So, anyway, you know that that's tails, correct? And that's heads. Right? And supposedly it's what's called a fair coin, which means that if you flip it, it's not more than likely to land on one side or the other. Right, like don't. Right? It's going to be like in the playoff game last time where they flipped it in the air and it just fell. It didn't flip at all. Right. All right. So this is an easy thing to talk about when we're trying to learn probability. Here's how the notation works. P stands for probability. H would stand for heads. So if you're talking about flipping what's called a fair coin, and again, a fair coin, Sophia, means that it wouldn't like land on one side or the other more often. It's like balanced, right? So then that would be 1/2, right? Because there's only one heads, and there's a heads and a tails, because there's only one heads, but there's a head and a tail. Make sense? Yeah? Okay. How about a deck of cards? Well, I have some, but I don't have them here. Oh, I do. No jokers. So, no jokers. So let's talk about cards. How many cards are in a deck? There's 52 cards in a deck, correct? For those of you who don't know, this is important because they ask you probability questions about cards, and they assume you know how cards work. There are 4 suits. Hearts, which are red. Diamonds, which are red. Clubs and spades. And those are both black. The lowest number card is 2, and it goes to 10. And then you have a jack, a queen, a king, and an ace, which makes a total of 13 cards per suit. 13 times 4, 52. 52 total cards. So like this would be the ace of clubs. And this is the jack of diamonds. And let's see here. This is the king of spades. And let's see. And this would be the 2 of hearts. Right? Okay. So, what would be the probability of randomly selecting a red card? 1/2. Why?
Because half of the deck is
Right, because there's 26 red cards out of 52. There's 26 red cards in the total in the deck, and there's 52 total cards in the deck. That's 1/2. Okay. I know these are all basic, but we got to get the basics down before we get to the stuff that's a little trickier. Matthew, we good so far? So far, so good. Okay. Now, what about this, though? This would be kind of weird. What about the probability of flipping the coin and getting 2 heads in a row? So here's the first one. I got a heads. See? All right, I'm going to flip it again. What's the probability that twice in a row it was a heads? 1/4. Whoa. Huh. And the reason it's 1/4 is because like this. Let's make a chart. Let's call toss 1, toss 2. Okay, so let's make a little chart right here. Because you're right, it is 1/4, but I want you to see why it's 1/4. Okay, Sophia, so toss 1 could be heads, right? And then toss 2 could be heads, correct? Toss 1 could be heads, and then toss 2 could have been tails, right? Is there any other way to have like toss 1 be heads and something different happen for toss number 2? No. So that's it. So then it could have been tails though for toss 1 and tails, and it could have been tails and heads. So you see that there's 1, 2, 3, 4 ways you can toss a coin and have the outcome, you know, toss it twice, and only one of those 4 ways. Right? Another way you can think about that is toss 1 has a probability of 1/2, and toss 2 has a probability of getting a heads. It's 1/2. 1/2 times 1/2 is 1/4. Yes, sir?
in the fact that there was one that you had to add those, how would you know when to add and when to?
Yeah, that's a good question. We're going to get to that. It's the difference between what's independent and what's dependent. So actually, we're going to get to the independent in just a second. Yeah. So let's see here. Any questions about tossing the coin? Okay. So, here's the next one. What is the probability of selecting a red card at random replacing it and then getting another, then selecting another red card? Here's scenario 1, here's scenario 2. Scenario number 2 is what's the probability of selecting a red card at random, keeping it, and then getting another. There we go, sorry. Poor Jesse not here today, missing something new. That's just a sad story, isn't it, Saul? Yeah. Mario, do you understand the difference between those two situations? Yeah? Sophia, you understand? Well, bless you. Bananas. Sorry. Do you guys understand the difference between the two? Yeah? And the first one you put the card back, second one you keep it, right? Would you guys agree with this? The first one's 1/4 because half of the deck is red. Take the card, it's red, put it back. Draw another one randomly again. It's the 1/2 chance again. In fact, this is what's called independent. It's independent because, like, draw 2 doesn't care what draw 1 did. It doesn't matter. You put the card back, so it starts all over. It's like flipping a coin. If I flip the coin 6 times in a row, what's the probability that the 7th time I flip the coin, I get a tails? Still 1/2, right? Because the coin doesn't have a memory. It doesn't try to keep it balanced. It doesn't know, right? So when you take a card out of the deck of cards, right? Got the card. Oh, red. All right. Put it back. Mix them up. All right. Put it back. Mix them up. Randomly select another card. Let's see. What's the chance that this card's red? 1/2. Okay, because the other one already happened, right? So, dang! So, but the chance of both of them happening one after the other is 1/4 because It was 1/2 for the first one and 1/2 for the second one, right? Because it could have gone like this. Let's call it D1 and D2 for draw 1, draw 2, okay? It could have gone like this. It could have gone red, red, like it did. It could have gone red, black. And it could have gone black, red, or black, black. That's 1 out of 4 ways that both draws are red. Do you see? It's 1/2 times 1/2 equals 1/4. This one's a little different because draw 2 changes because, oh, let's see. What's the chance I pull a red card out right now? 1/2. What's the chance I pull a red card out 3 times in a row?
Well, if you're replacing it or not?
No, not replacing it. 1/8. How'd you get 1/8 so fast? It was 1/2 times 1/2 times 1/2 is 1/8. Okay. Oh, what a failure. I'm a loser. All right. Okay. Now, so I pulled the red card out. I still have the deck of cards right here, right? So throw it on the side. How many red cards are left? 25. So the first one I had 26. So I had 26 out of 52, correct? That was for draw 1. For the second one, how many cards are left? 51, and there's 25. So it would be 1/2 times 25 over 51. So it would be 25 out of 102. Is that right? That is a funky 5, isn't it? See, the second draw is not independent of the first one. There's a memory, kind of. I mean, you know, like having this card not in the deck changed the game. It changed the chances. Does that make sense? Okay. All right. I know that didn't answer your question, Jubin, about the adding, but we'll get to that. Hey, I got a question for you. I want you to try it. What's the probability of getting 4 tails in a row on a coin toss? Did I say coin toss or coin toss? Is that right? Yeah? So no problems. Okay. I guess, you know, a lot of what I'm doing with this lesson is making sure you understand, number 1, that probability works the way it does, which I think you guys know. Right? But number 2, Ruby, making sure you understand the things that Cambridge uses when they ask you questions. One thing they ask you about, and I don't have one with me, I don't think, is dice.
Is it going to go above the 6-sided die?
If it did, it'll tell you. So dice, they're 6-sided, right? What's the probability of rolling a die and getting a 3? Because there's 6 numbers, right? So that'd be 1/6. What's the probability of rolling an even number? 1/2. What would be the probability of rolling a 5 and then rolling an odd after that?
1/6 times 1/2, so 1/3.
So the probability of rolling a 5 would be 1/6. The probability of rolling an odd number,
112.
are we good? All right. What's the probability of not rolling a 1? 5/6. Okay. Here's the thing. What's the probability? This is our last example, I think. Now we got 2 examples. What's the probability of rolling twice? Okay. Rolling 2 times. And adding them. The outcomes. And the sum is greater than 10. It's on like Donkey Kong.
You only have 6, so 1/30. 6, then there's 6 left.
So
Yeah, Multiply that 35 with like 6.
Say it again? Well, greater than 10. Does 10 count? Okay.
Wait, no. And then 6. Greater than 10.
So is 10 greater than 10? All right. So it's got to be 11 or 12, right?
Wait, look. Well, no, the thing is, you can get the first 6. I mean, you can get the 5 in the first. Or you can get the 5 in the second. No, 1/3 is
200. What? 260. Wait, but I feel like that's right. No. Yeah, it's 218. Wait, let's see.
There's only 3 options, right?
Yeah.
Okay. How can you get a 5 and what's the probability of getting a 5 and then a 6? 112?
no 136.
136. So the probability of rolling a 5 and then a 6 is 1 over 36. Okay. What's the probability of rolling a 6 and then a 5? Right? What's the probability of rolling a 6 and then a 6? Well, 136. Because when you roll it the first time and you pick it up and do it again, it doesn't remember, right? Okay. So then, if you add all those together, why would you add them all together? What's that? Because it could happen this way or this way or this way, right? So, is that right? Does that make sense? So I mean, if we rolled 2 dice, more than likely, if we rolled them 12 times, more than likely, only once, if we added them up, it would be more than 10. Is that what that means? Oh, should we get some dice and find out? Heck yeah, we should. Somebody left a note.
We should like write all over.
Yeah, so don't get blessed.
You don't want to play the you looked at me weird.
Oh yeah.
Well, I can't find my dice.
Oh, damn, that's some good Wi-Fi right there for you.
No, that's internet. Or that's
What do you use? What do you use, Mr.
AT&T.
It's AT&T? I know, I was going to get Verizon.
All right, here we go. Okay, you ready? You ready? So this is trial number 1. You guys have to help me keep track. So the first one is a 4.
Yep, we already have.
We already lose, don't we?
Yeah.
So that's 1.
So that's one trial that was a no-go. Okay? Okay, let's try it again. 5. 5, okay. Dang it. That's 2, that's no-go. That's supposed to be. All right, 5, okay, that's good. 4. Oh.
This is the probability of a 5 and 4 happening again.
2, no good. 6. 6!
Yeah. So the rest of them shouldn't have.
So then, let's see, that was our 5th trial, and it finally worked. Should happen 1 out of 12 times. You know, it was weird. You guys were complaining about, or not complaining, you were just saying, hey, look, it did a 4 and a 4 and a 5 and a 5, like way too much, right? It's weird. If you were to flip a coin 100 times, and it was really random, you're going to have about 7 in a row that are the same in that 100 trials. That seems completely unrandom, but it is. In fact, one of the ways that people detect fake random, like when people lie about money or whatever, is it looks too random. Like random stuff has patterns. It looks like it has patterns, but it doesn't.
Okay, how do you know it's 7 times in a row if you did it 100 times?
Like if you did it 100 times and you recorded it,
Yeah.
7 times in a row, you're going to get like the same outcome.
How do you know 7?
I mean, that's just how the math works out.
Wait, does it have to have 7?
No, but it's more likely than not that you're going to have 7 in a row that are heads out of 100 or tails out of like 7 in a row out of 100.
How'd you get 7 and not like 8?
That's just how the math works out. Yeah. All right. Okay, next one. This is our last one right here. So we're going to talk about a deck of cards and our dice. Yeah. Deck of cards and our dice. Okay? Last one. What's the probability of choosing a red card and then rolling a 4? Probability of choosing a red card and then rolling a 4. Hey, do you see what I have a picture of right here? So this is red card, that's black card, right? There are, let's see, 6 of these and 6 of those. There's a total of 12 possibilities, right? And only one of those possibilities is red and 4. Right? Is it 1/12? Yeah? You could also do it this way. The probability of getting a red card is 1/2. The probability of rolling a 4 is 1 out of 6. That's 1/12. Are we good? Okay. So I think you should definitely be able to do 2 things today. I think you should be able to finish your homework in class. And then you should also have time to work on that packet I gave you. Yeah. That's easy. Oh, the whole thing? Yeah. So also check this out on the 26th. 2/26. That's 2 Fridays from now. In class, for grade, paper 2. No, it'll be like your. So you guys, listen please. Jubin's question is that like a practice thing or for real? Is it a grade? It's a grade. So yeah, it's a test. So it's going to do 2 things. Number 1, it's going to be our midterm, so our quarter final. Number 2, it's going to be used as the predictor test. So with Cambridge, I have to submit some paperwork that says if Saul is in the hospital on the day of the test, this is what grade he deserves. And I have to use something official to use a predictor.
Wait. So like, you can do like really good on this.
Yes.
Like,
So this is big.
then you kill it. Why kill yourself?
Well, not kill yourself, right?
Then what's the point? And then like not come to school that day.
No, like you can't just not come to
Well,
school.
like if you have like.
It's
you
got to
have
be.
sickness,
No, I mean it's really. You got to be really, really sick.
Well, yeah, I know.
Yeah.
You know,
Like not something you're gonna fake.
But
Like
still.
so far, this is our 4th year doing Cambridge. We've only had 1 kid that worked for, And that's because during the middle of the test, she just violently vomited.
Oh. Ew.
Yeah. I mean, you're not going to just stay home sick and then Cambridge is going to be like, okay, you deserve that predictor score. But that's what this is. So it's two things. This is going to be your quarterfinal. So it's going to be a big part of your quarter grade. And it's also going to be the predictor.
What happens if there's like a funeral or something on that Tuesday?
I don't know. I don't know.
Can we take it later? Like, come on that?
No, there's no makeups.
No, well, it doesn't really matter because, you know, you can
Hold on. All right, hey, you guys, please stop talking. What was your question, America? Oh, she forgot. All right. Yes, then, sure. All right, so listen, here's the thing about this. This is what makes me nervous, Mia. Paper 2 is supposed to be an hour and a half, but we have about 55 minutes. You have 55 minutes. This is what we did last year. It worked out fine. Because you're going to have lots of paper 2s to practice between. Well, you already had one. You got one right now. Probably going to have another between now and then. You're going to know how they go. Paper 2s are pretty easy, really. Now I'm going to grade it very strictly according to the Cambridge thing, and I'm going to use their curve to determine what grade you get. So, yeah, you're going to be fine. Questions? Yes, sir, Jubin?
Do you know, like, what the curve is right now?
I have no idea. I haven't looked. What's that?
Have you made that test yet?
Well, I'm going to use last year's paper 2 from 2015. Okay, your homework is in the brown book. It is page 403 and 404, number 1 through 5. So, Saka book.